Good day to everyone and good evening from sunny Dubai. Today we will talk about the promising technology of nuclear fusion, which can revolutionize the energy industry. Our guest is Dr. Yeshayahu Eisenberg, CEO and co-founder of Metatron N.R.G. He leads the project to create compact nuclear reactors which are designed to change the entire energy industry. Metatron is working on the development of tabletop reactors, an affordable and scalable alternative to fossil fuels. In the future, such installations will be able to provide energy to both homes and industry. Dr. Yeshayahu, warm welcome and thank you for joining us today.
Thank you for you.
Okay, Doctor, I have so many questions. And the first thing that comes to my mind when I hear a tabletop reactor. So, how big is the device, and is it safe? Like tabletop nuclear reactions?
It's fully safe, but it's quite small, and the heart of it is really a tube, small tube. However, there is the facility around it, so probably it will be in the size of a desktop computer. This is the order of magnitude. The reason it is safe is due to the detail of the technology, okay? Because it generates fusion in totally different way than the usual hot fusion reaction, the reaction which take place in the sun and on Earth in hot fusion project, which are going on for at least last 8 years. So when we will enter into the detail of the technology, it will be easier for me to explain why it is safe.
Thank you very much. So basically, it's as of now the size of a desktop, right? Like a computer that can be placed on the table and could be the source of energy.
Yes, the basic idea that there are entities we call plasmoid, which I'll explain in more detail afterward. And these plasmoids are in the size of a few micrometer. And this plasmoid catalyze a fusion. So basically, if such small entities catalyze fusion, so you can understand that the device doesn't need to be very big, because they are very tiny, and even if we have a huge number of them, still they are not occupied a big space. This is the main idea, okay? And the way that the fusion process, okay, take place, the channels through which the fusion is taking place is a little different within this plasmoid, especially in water, but also in general, than in usual processes of nuclear fusion. And this is a matter of fact, and it's a matter of a lot of experiment which were done, and not just by ourselves, but also for many others, shows that there is not any radiation. And actually there is a theoretical question why it is so. And there is some explanation for that. I'm not sure that anyone fully understands the reason, but this is, let's say, this is experimental fact.
So before we go into the details of the device, can you briefly tell our viewers how you came up with this idea? Like, this is really fundamental research, and this is truly, we can say, breakthrough in the science. So how you came up with this idea? What was the path to this?
Actually, it was not my idea. Okay. Long ago, I met Clara Salai. She has an idea to a setup which is supposed to generate fusion. She worked with some professor of physics from Bar-Ilan University. He was very excited about these ideas. and they tried to explain me what they are doing, and I didn't understand anything. And I also didn't believe that it will work. I was quite skeptic. And later on, I became aware to a work of scientists called Ken Schulders. Ken Schulders actually discovered this kind of plasmoids, okay, in the early 80s of the previous century. And he discovered the kind of plasmoid which can live for, well, okay, people argue that they can live for hours and beyond. And this is very exceptional, because plasmoid, you can find plasmoid also in hot fusion. But in hot fusion, or in hot plasma, let's say, leave aside the fusion, in hot plasma. But in hot plasma, plasmoid live for a microsecond. And if someone come and tell you that there is plasmoid which can live for hours, so this is really, if it's true, this is really a big breakthrough. And because they are so dense, so they keep the cation within them so close, let's say in distances of about tens of picometer. In these distances, the nuclear fusion has a probability to take place. And since they are there for very long time, as long as the plasmoid live, they are very close to each other. So then, if there is probability, eventually it will happen. This is the idea. And actually, we are not the first to argue that this kind of plasmoid can catalyze fusion. However, what we did eventually, in our system, there are three kinds of plasmoid which are generated. And especially we have some new kind of plasmoid, which is fully stable. Now think about that. We have a plasma, okay? We generate plasma underwater. This plasma is arranged itself in the form of, let's say, tiny vortices. These tiny vortices are guided by their own magnetic field. You know, we have vortex of plasma. Vortex of plasma mean that there is current. Current generates magnetic field. Magnetic field implode further the tiny vortex. When it implodes further, the magnetic field becomes stronger. When the magnetic field becomes stronger, it further implodes until it becomes very, very tiny, and eventually it closes itself to a form of let's say, donut or torus. And this is the plasmoid. So this is the usual way plasmoid are generated. And this plasmoid, which were discovered by Schulders, these plasmoid are dominant by electrons and not by cations. So there is much more electron in this plasmoid than cations. However, the cations, which are trapped inside this plasmoid, can reach such can be close enough to fuse and to generate fusion. The basic problem in fusion is that there is a repulsion because of the Coulomb. You have to overcome the Coulomb barrier. I mean, the cation has a positive charge, and if they're repulsing each other because of the positive charge, and you have to bring them close enough, but you have to overcome the Coulomb, the electric barrier, and this is the challenge, because the fusion, if they are close enough, the fusion take place spontaneously due to the nuclear force. So this is the main problem in fusion in general, to make the cation close enough, and because the huge magnetic field, which is keep the plasmoid together, and also because of the screening of the electrons, they can reach such proximity within the plasmoid when they can fuse. And this is the general idea, and this idea is in the market for quite long. And we add to it something very essential, which is to generate new kind of plasmoid, not of the kind I described so far. Also, we are also generating the kind I described so far. We generated actually three kinds of plasmoid, but we generate new kind of plasmoid, which is fully stable. When I say fully stable, it lives in the lab for, let's say, for more than half a year till now. So I assume that if it lives for more than half a year, so it will live forever. Forever is a big word, but in principle, it can be considered as a stable creature. And if you have stable creature which generate fusion, so then you are in business. This is the idea.
This is interesting. So you mentioned that it was your, if I can say so, scientific partner's idea, and you basically made your part, from the technical side, to make it a reality, right? If I understood
yes,
you correctly.
In the beginning, nothing is complete from the beginning. So there were some addition to the original idea. It took time. It took many years to convince ourselves, especially to convince myself that it's something which really can not just first of all work and second to lead to something commercial. It's two different things. You have effect. If effect doesn't mean that this is commercial. So it took many years until we convinced ourselves, and then it took another time to raise the money for it. To do a project, you need money. And then we got a stage. Right now, we are in a stage that we actually show the proof of concept. And now the mission is to enhance in order of magnitude what we already have to have something commercial. So this is the general idea, and this is generally our present stage.
Thank you very much. In regards to physical principles of the technology, you mentioned, if I'm correct, cold fusion and nuclear fusion, if I'm not mistaken. So the device uses different physical principles, or it's like one of them, as you mentioned, cold fusion. Maybe you can elaborate a little bit on this part.
I really don't like the notion cold fusion. Okay, we are doing plasma. And cold fusion usually regard to something different. Today, all this field which contain many directions and many ideas and many different ideas and many different paradigm and many different models. So all this field is called today a low energy nuclear reaction and or linear actually. Okay, low energy nuclear reaction, it's linear. And look, this plasmoid are extremely energetic. So the low energy, to say that it is low energy is not something that really fully explain the idea of plasmoid, but practically people like classification. So we will be classified as a low energy nuclear reaction. Belonging to this field. You can do nothing about that. Again, the new thing that we have really, there is other project which are running today, which are, there is the N.G. which are also doing things like that. But the advantage of what we are doing is that after you generate the plasmoid of our kind, and because they are stable, you don't, and if you generate enough of them, there is not need to further generate it. So there is two stages. There is the initiation stage in which we are generating the plasmoid. This takes place in the lab. This is something we are doing in the lab. We are using quite high pulses, quite high voltage, 20 kilovolt, also very high frequency and very short pulses. The pulses are of the order of magnitude of a few nanoseconds. So this is something that you are doing, and this with a special magnetic fields, special configuration, special materials, etc. This generates the plasmoid. The plasmoid, our plasmoid, are staying on the bottom of our tube, and now you are going from the high voltage pulses to very low voltage DC voltage, okay, between 20 to 50 volts, let's say, okay? And actually, this plasmoid, which you generated in the initial stage, when you give them a continuous DC potential, they start to to arrange themselves in collective structures. And also, the single plasmoid is very small. This structure you can see with naked eye. Okay, you can see this structure. Okay, this is quite big structure, which is a constituent of a huge number of plasmoid. And then when you are in the DC, you can further manipulate them by different means. And eventually you are starting to get the event which express themselves as a burst of explosions, small explosions with shock waves and okay? And this generate energy. However, in this stage, we don't have enough of them. The frequency of them is not enough, is not high enough to have a commercial reactor, okay? So actually, what we are doing now is we are developing the system to a stage in which it will generate this event almost continuously. So this is in general the situation.
The further we go, the more interesting it becomes. So what form factor do you plan for the device? Will it be like a sphere, like will the user will be able to see like, I don't know, some light or actual the plasmoid, and what materials do you plan to use for it?
Look, right now, and let's say that, for apartment, houses, small businesses, we need something which will lead, let's say, 10 kilowatt. Our next target is to achieve around 10 kilowatt. For 10 kilowatt, 10 kilowatt is not so much. And we are using tube. Okay, we have a tube. Everything takes place in a tube. Okay, the tube itself is very small. It has a diameter of let's say between 50 millimeters to 80 millimeters. Okay, that's around the size we are working so far. And of course, in the future we can do something bigger. But right now that's what we are doing. So, and this tube and the material which are within this tube are the heart of the generator, okay? The generator will need always some small DC input, okay? It can be a battery, or it can be, you can take part of the output and put it as an input eventually. Usually it uses between, if speaking in terms of power, it needs between half and 1 watt, which is nothing, as an input, and it needed just to rearrange the plasmoid to certain structure, okay, which is important because just when they are arranged in this structure, they generate the nuclear fusion. So actually, I told you that the final reactor will be in the size of, let's say, a desktop computer, but the heart of it is something very tiny and very small.
Thank you very much. This sounds pretty interesting. And in today's world, there are a lot of talks about fuel-free generators. And it seems that the technology has been, different types of this technology have been developing since like a long time. And only right now the world is talking about more sustainable and more clean ways to get the energy, especially in spite of this weather calamities. In your device, how first you become with this idea to use the plasmoid as the source of energy, and why the plasma itself?
It's something which is people are talking about it for quite long, because there were many experiments that show that when you do let's say plasma or plasma discharge underwater or within the diluted gas, you are getting materials will not exist before and could be generated just in nuclear reactions. Okay, so that people knew. The special what we are doing different is exactly to generate different kinds of plasmoid which are more promising with the respect of generating energy, because they are stable. So you don't have to continuously generate them, like for instance in other projects. In other projects they continuously generating the plasmoid. It means that they continuously generate plasma, because you generate plasma and then the plasma generates the plasmoid, and the plasmoid are catalyzing the fusion reactions. So in our case, our idea, what is new in our idea is that once we generate the plasmoid, our new, so then you don't need to continue to generating plasma, to generate more plasmoid, because we already have them. They are stable. They are not decaying. And if they are not decaying, we don't have to generate continuously new plasmoid. So it makes all the system much simpler. This makes everything quite different, because you have a small tube. Okay, even if you take let's say you take off the external DC power supply. Okay, so then if you turn it on, so the plasmoid are staying there. You are not losing them. So it makes everything much simpler.
This is interesting because maybe different people, when they hear the word plasmoid, they understand different things. I saw like some research that plasmoids were observed in the Egyptian pyramids when the scientists were doing the photos, and they saw this like sphere type beings. Now, in your device, you're talking, if to summarize for our viewers, you said in this tube, there would be like a circuit which creates the torus and creates plasma, and then plasma becomes the plasmoid. So maybe for the viewers who are not that deep into the science, maybe you can explain in a few words in the context of your device, what is plasmoid and what makes it different from other devices, or how different is the plasma and when plasma turns into plasmoid.
In our system, okay, there is technically there is several main and even I will say essential differences. And there is always, we are generating plasma. This is a general thing. This is not particular to us, but we are doing it somehow differently. Inside the tube, we have two kind of liquids. We have heavy water, what is called the deuterium oxide. We need the deuterium for fusion. To deuterium, going to helium. In usual fusion, they can go to helium-3 and tritium. In our case, it's going to helium-4. Okay, in general. And we have another material which is heavier, which is a liquid, which is the heavy water is isolated, of course. I mean, pure water is quite isolated, and the other liquid is heavier than water, and is conductive, okay? We have a conductive material, which usually is also saved as an electrode. When we are doing as a nanosecond pulses, so except generating plasma, we also generate within the heavier liquid something which called Coulomb explosion. So the new kind of plasmoid are generated also because the Coulomb explosion, and eventually there is a certain combination of all kind of plasmoid, because the new kind of plasmoid, the heavy liquid cations, when they in the process of the generating of the plasmoid of these cations, they swallow whatever came across them, and whatever came across them is deuterium cations, and also the other kind of plasmoid which were generated by the more ordinary way of plasma discharge. Okay, so eventually we have something that you can say it contains all the kind of plasmoid in one entity, and somehow this entity is stable. So we have here two principles. One principle is Coulomb explosion, and for that we need the very high frequency. It has to be in the pulses has to be in the order of magnitude. It's not just high frequency; it also should be very short pulses. And few nano is really very short. And you have the ordinary way of generating a plasmoid from plasma, and part of these plasmoid which are and the plasmoid which are generated from plasma are semi-stable. They are not living for eternity. The plasmoid which are generated from the heavy liquid are stable, but they also swallow in their. I'm doing it. I'm simplifying things, okay? But in the process of their formation, they are, as I said, swallow whatever come across them. In this process, it includes also the other kind of plasmoids. So now we have a bunch of material within this plasmoid. We call it Metatron. This is we call this plasmoid Metatron. This is also the name of the company. You know, there is an electron, there is a proton, and there is also Metatron. And actually, this creature is the heart of our invention. This new creature, and then it has. I just have to say that it has to be further manipulated in what we call the continuous stage. When we just put a low potential into the system, so then the system can work on this low potential forever, and we can also continue to manipulate it in different technology to enhance the appearance of the fusion event.
Thank you very much. So I was saying that from what I understood, the device will be preset in the lab with this high frequency, as you mentioned, that you start the reaction, you stabilize it, and then once the reaction is stable, the plasmoid, like you said, is generated, it's living, and to stabilize the reaction, then only it will be given to the end user. And if you can share, this frequency, from what I understood, is generated by the sound waves, or
no, this frequency is electric. It's electric pulse. It's not sound pulse. Sound pulse can also play a role here, okay? But not in this stage. Ultrasound can be relevant. I'm not saying that not. But in this stage, we have the pulses are pulses of a very high voltage, about 20 kilovolt. This is usually what we are working with. We can work with a little more, with a little less, and also very high frequency. High is something relative. when you speak about 20 kilovolt, so high is, let's say 10 kilohertz is high. If you speak about RF, this is this is very low, okay? But for very high voltage, this is high, okay? And we are working for 10, 20 kilohertz. We go over all these parameters, very easily. But believe me, that every step here is very important, and every parameter is very important. And if you are not working with the right parameters, nothing happens. Okay, it's not. It's what I'm saying here and what I'm describing here is not trivial at all. And so you have to be very accurate in the parameter you use to generate this kind of creatures.
And from what I understood in the user perspective, this safety of the device will be because it's low reactions.
We are speaking here about the final device, okay? In the final device, as I told you, there is no radiation. In general, fusion is considered as a clean energy. Everyone, fusion is much cleaner than fission, right? So in general, it is almost true, but there might be neutron radiation. Neutron live for, let's say, 9 minutes. The half-life of neutron is 9 minutes. So it's not something that live for, for 1,000 or million of years, like in fission, but still, you prefer not to have it. There is channels which are totally clean, okay, and there is channels which are generating neutrons. However, and this is true not just for our device, in general, the channel that generate fusion with plasmoid is always clean, is always without neutrons. Okay, this is experimental fact. I mean, it's not, there is model which try to explain it, but this is experimental fact, okay? No radiation.
And maybe going back to the technical details for more sophisticated users, what parameters, temperature, voltage, pressure, are required to initiate this reaction, and what parameters do we need to sustain it?
To generate it, we need, first of all, this kind of plasmoid in general, it's very important that that they will be generated in what is called the endothermic process. It means, let's say, it means cold process. If something warm up, this plasmoid will not be generated. And we are using, as I told you, very short pulses. So this very short pulses doesn't. They are so short that it will not. It is not warm up. I can apply these pulses for hours, and the system will. The temperature will change maybe in a few degrees Celsius. So this is one thing. And if you ask about more technical things, so we also, as I told you, we are using a pulsar, which has in the initiation stage, a pulsar which have 20 kilovolt, let's say at least 10 kilohertz, and a very short width, about 5 nanosecond. And of course, we have electrode, we have special electrode, we have these two liquid, as I said, and basically that's all we are doing. Okay, we have also magnet. We have a very strong magnetic field around it, around more than 1.5 Tesla, which is quite much. But after we generate everything, the magnetic field are optional. It's not essential. But after we generate it, when we generate it, we need this magnetic field. It's quite essential. And okay, it's actually as simple as that. Of course, there is configuration of the electrode and but this is too technical details.
Yeah, actually, I wanted to ask because maybe for me sometimes a lot of technical details, but it was crossing my mind that maybe the magnetic field or this like torus, which
The
helps
what?
to the magnetic field you mentioned. Do you understand correct that it helps to sustain the reaction and to get the stable work of the device?
It somehow help in, there is some rotation, there is some synchrotron radiation there, and it turned out that all these things which are going are important for certain reason. And I will be honest with you, I not fully understand why. There is a conceptual view. There is, and many things during the time we make the experiment, we change our mind. We understood that it is not going exactly as we thought, okay? And there is phenomena which I'm not able fully to explain. This is a new field, So there is the conceptual view. I'm working within this, but there is also the experimental results which, guide us.
You mentioned something interesting is happening that maybe from the scientific point of view, not always to be explained. Are we talking about something which is, if I'm not mistaken, again, called ether, or some other field that we were missing before in the science, or this is something else?
You're referring here to something which called zero-point energy, right? Am I right? You know what is zero-point energy? It's, what you call ether is, okay, let's say this is the physical vacuum. And the physical vacuum is has an infinite energy within it. Okay, this is well known. I mean, about that, every physicist will agree, okay? The problem how to extract this energy. And except fusion, we have quite strong indication that actually we extract also energy from the physical vacuum, and this is called zero-point energy. So I didn't think that we will talk about that, but this is actually more exciting than fusion, actually, because this is the infinite infinite amount of energy, and to extract energy from that, this is really the ultimate goal. I actually believe that our system could do it, okay? Could do it. And even we have certain indication that it do it, except the fusion event. We had also another strange phenomena, which I consider as extracting energy from the physical vacuum. There is what is called Casimir effect. And Casimir effect is that when you take two plates, okay, and you bring them very, very close. So there is some attraction between them because the physical vacuum, because I'm not going to go to the details. This starts to be quite, this is related to QED, to quantum electrodynamics, in general to quantum field theory. And the interplay between this plasmoid can play this role, okay? And the interplay between the Casimir effect and the magnetic dipole of the plasmoid, which is very strong, so it might cause them to vibrate. And when there is a vibration of the magnetic dipoles or magnetic charge, so this is radiation, right? This is energy. And actually, we have seen something like that, but it's too early to give big statement about it. But yes, I have a great expectation from this system.
And in the course of your work, can you share some technical challenges that you faced, or maybe some interesting? You already mentioned some interesting things happening, but maybe you can as well give a few examples of difficult challenges and some interesting discoveries that you did not expect, but they revealed themselves.
When we started, what I have in mind is the ordinary non-plasmoids of Schulder's. Okay, what Schulder's discovered. I didn't expect this new kind of plasmoid, which are fully stable from the beginning. So this is, this is the main thing here, and this is something which came with surprise. We didn't expect it from the beginning. And the challenge for the future, I can tell you what is the challenge for the future. While the protocol of generating plasmids is fully defined. Okay, we know how to generate more and more and more plasmoids at will. And then there is, when we have them, and we have to further manipulate them on the continuum DC mode. So then the protocol for that is what we are working now. Because once we will have the protocol, so it means that we can systematically enhance what we already have. And then the sky is not the limit. So that's what we are working now. When we will have the full protocol for that, and this protocol involve, some manipulation. You mentioned the sound wave and such kind of things. What else? What else surprises? I mean, in such work you have many surprises, and in such work, the beginning nothing works. It starts by stage where nothing is working. You're doing whatever you thought that should work, and nothing works. Until you understand that the fine-tuning, which is essential. Now, the fine-tuning is essential, always, all the way, in such kind of thing, because this is very subtle work, eventually. It's very easy to miss something. If it was so simple, so people were discovering it a long time ago, right? You have to believe, If you believe, you have, you are ready to work on it more and not give up. And when you are not giving up, so eventually it works.
So this is what motivated you not to stop. You really wanted it to happen.
I was sure that it should happen. So when it didn't happen, I could say, okay, I was wrong, or I'm doing something wrong. Two different things, right? So eventually it works.
This is great. And what confirmed results have you already obtained? Are there any measurements indicating nuclear reactions or high energy output?
Yes, when we have the best, as I told you, we reach a stage in which, there is just water and some liquid. Nothing should happen within if the input is low voltage input, okay, with very low power, okay, 0.5, 1 watt, which is really nothing, and you start to get burst of energy express themselves as an explosion, shock waves, and an arc discharge. How actually we reveal that something is happening? The system work all the time. I came in the morning, we have the fuse, and the fuse burn out. So I say, okay, who knows? I replace the fuse, and then we understood that fuse cannot be burned out just like that. Something happened during the night. So we looked more carefully into the system, and then we have seen the phenomena. And then even if we put a fuse of 6 ampere or more, this fuse also burn out. So we have a good indication that this burst of energy, that this burst really generate energy. However, as I said, in this stage, we don't have enough of them per given time. However, we had the system that continue to generate them for several months, more than half a year. It continued to generate them, okay, without touching it. So this is our indication that we have fusion. I mean, these two materials, nothing can happen in normal circumstances. Nothing can happen with this material and this voltage. I mean, you can take it and you can wait for eternity. It's really nothing. Very low, a very low current. Let's say usually 10 milliampere or something like that, and suddenly it jumped to 10 to 6 ampere or something like that.
Dr. Shaike, you mentioned that plasmoid can exist for quite a long time. And what are the current efficiency indicators?
Usually people in fusion, they are speaking about Q. Q is the ratio between the energy you invest in the system and your energy that you get from the system. And this is not very relevant to our system. First of all, as I said, in this stage, we're just getting a burst of energy, so not something continuous. And second, it doesn't matter how much energy the system will generate. It will need always the same amount of input, because the input is not playing a role in generating energy, it's just playing a role in organizing the plasmoid. The plasmoid needs this external low voltage to arrange themselves. And it will be the same voltage and the same energy input. So if you want more energy, you have to put more input. More output energy, you have to put more input. And in our case, it will not be like that. In many approaches to low energy nuclear reaction project, okay? What they are generating is heat. In our system, we will generate directly electricity. So we are not expecting to that our system will be warmed very much, maybe a few degrees. We are not looking to heat the system to get energy as temperature, but to get energy as directly as electricity. And by that this is also different from most other approaches, because in most other approaches, what you get is actually heat. And then you can, transfer it to electricity in the ordinary way. Because heat gives steam gives, etc.
Thank you. So pretty much we already discussed that the device, from what I understood, is quite safe. And you mentioned low energy nuclear reactions. And from the use perspective, we put it in some wall compartment or something like that. So one question arose in my head. So the charging will be via wires or wirelessly, or like both options? And the second question, just to summarize the safety features and what will be built into the device, just in case to protect from whatever might go wrong.
Look, I understand that when you hear about something nuclear, fusion, whatever, it seems to you something, oh, this is very dangerous. I'm sure that there will be regulatory problems, because people have something in mind which is not necessarily connected to reality. So I can assure you, this will not be the problem, because the special nature of the plasmoid. Here we really can control how much energy we can generate. And in this stage, we just can pray that we really will be able to generate such amount of energy that you should worry about. We are very far from there. And anyway, this system is controllable.
We spoke about the safety measures that, of course, when people hear nuclear, the only thing we know is that nuclear power stations and some historical events that happened. So we discussed that the device will be safe, and for sure there would be a lot of lab tests before it will be out for the daily.
Of course,
use?
there will be also pilot before you maybe start to sell it. I mean, we want to see that this work for a long time, and so at least 1 year pilot there will be. Clear.
Okay. And in terms of use and the charging, let's say with this device, I want to charge my phone or like my laptop or lamp near to my bed. So, and the device will be, let's say, in the wall compartment. So, what kind of ways of charging there would be, like the standard ways that we are used to the cables, or they would be accessible wireless charging. Let's say if we have one device somewhere in the house, in the middle of the house, it would be enough to wirelessly charge all the electrical devices. Can you elaborate on this part?
In this respect, it's not different from any other source of electric energy. Okay, so it just will generate electric power. So what we have in mind is that it will supply the electric power to all house, and you will continue to live and charge things as you are doing today. Just you will be. You will have something which is off grid, or the grid will be just a backup. This is the idea. I mean, so if it generates the power which is needed for all your apartment, all your home, so that's what you need. And then you can charge your phone or whatever in the usual way, because you have now electricity, and you are not care anymore from where it comes. It's the same. It will be the same. For you, it will be the same as the electricity you have now. Okay, no difference.
And can you share a little bit more on the stage of the development that you are at now? So you mentioned that there would be as well at least 1 year of laboratory tests. So when possibly we can see the prototype, the working device, and when will you be ready for the mass production?
The plan is to have a commercial prototype in 3 years, and I believe that it will take another 2 years to after we do a pilot and all that, and to start to really sell the product. 5 years from now, maybe less. But I like to take not to promise something and then to disappoint someone. So I believe that in 5 years we should do it.
Thank you. And yeah, it's a good approach to announce 5 years and then do it in 2 years. Then it would be impressive, rather than to say we will do it in 6 months and then it will take 5 years.
We will do it as fast as possible.
And what can be possibly the price for the end user, and what could you perhaps share an approximate cost of the device in the mass production?
Look, I will tell you. I can tell you right now what is the price to produce it, okay? What will be around. I think that it will be between $3,500 to $5,000, rough estimation, okay? So then you can ask how much we are going to sell it. However, there is 2 options. We can rent it, or we can, as usual electric company, take according to how much you use, right? We also can do that, or we can sell the product. There is two options, and we can do both, or choose one which seems to us better. Eventually, we have to decide about it. When you buy some TV which is in state-of-the-art TV, so you pay more, and then when I buy it, so I pay less. So this will be the same. Because of that, I don't want to give numbers. I can tell you how much it will cost us to produce it.
Well, still, it's quite impressive, even if the price for the, let's say, standard household would be $10,000 or $15,000 roughly. That sounds good. If you say it will be enough to, let's say, the 2 or 3 story house, 200, 400 square meters house, and all the devices. And how long possibly we would be able to use the device, and will there be any repairs or maintenance required?
Such kind of results they can work for 20 years in principle. I mean the amount of energy which contained in this plasmoid is enough for quite long. I mean for many years. Okay, the energy which is contained in one let's say cube of nuclear fuel with when you compare it to chemical fuel, so it's many million times more. So you should understand that such a small amount of heavy water is enough for many years. Anyway, on the worst case, you can take the tube and redo all the initial process, and this costs almost nothing, right? And then we bring it back to you, and you continue to use it. But I expect that it will work as is for many years. With any, but this is something. Because of that, we are going to do some pilot and to see that everything that we expect really work as we expected.
This is really incredible. Even if device costs $20,000 and will last for 25 years, you are getting the electricity source for like $1,000 per year. If we consider all the costs and bills that we pay today, I think it's still will be a good deal. And you mentioned that with time, maybe the cost will be even less when the more devices will be produced. Okay, so do I understand correct that pretty much the product does not produce any like harmful byproducts, or it does not have to be specially recycled or something like that?
You understand correctly. Yeah, this is totally clean energy, and in principle, such kind of project, our project and some similar projects which are running around the world, might change the direction of the climate change.
Oh, it's actually, you're reading my mind. This is what I wanted to ask. In the view of these events that are happening today in the world with all these floods and earthquakes, even though the answer already that we have discussed here is more than obvious, but can you tell to our viewers how can your technology help address the environmental and climate challenges we are facing globally today?
I mean, this is, it's almost obvious. I mean, if you have clean energy, look, it's not necessary that it will be just our project. There is also other projects. There is places to many. Not I always, I believe that everyone believes that he is the best technology. But anyway, the important thing is that we have to change the direction we are going today, because the end will not be so good, most probably. So we are doing our modest contribution to that, and maybe if everything will go well, so it will not be so modest. It will be something essential to change the direction, because the fuel we are using today is one of the main things which cause the climate crisis.
Yeah, we've touched big topics today. My final question will be almost obvious: how your technology might impact the global energy market.
The energy market is the biggest market, and look, once there will be a fusion energy, when fusion energy will be available for all, this will be a dramatic change in dramatic geopolitical change. I mean, it's not just, the energy stands behind everything, even if we are not noticing. Without energy, there is not progress. Energy is the most basic thing. And when you have limitless clean energy, everything will change. This is, I think, clear to everyone. But right now I'm modest. I just want to, I have a lab and I have a project and I hope to solve it. If by accident it will change the world, okay, be my guest.
This is very interesting, and as far as I understand, as you previously mentioned, the implementation field is limitless. We can use it in cars. We can probably use it for space exploration and for underwater world exploration, etc., and etc. And probably my final question would be, because we touched a little bit these topics today, because a lot of maybe fears these days, right? Maybe one of the first questions that I was asking you, how safe is the device? So this first thing that comes to people's mind, and again, how your technology can influence the energy market. Again, we as human beings sometimes are afraid of something we don't know, we don't understand. Sometimes we don't want to change the comfortable things that are already working for something new, even though it's like incredible innovation. So, in your opinion, what is the right balance between that, going out of the comfort zone, stepping over humanity's fear to move forward as humanity, as the civilization, and being cautious and making sure that all the precautions and safety rules are taken into account?
This kind of project doesn't have the problem as, let's say, AI project have. Because AI project, we're happy to have AI, but we also worry what will happen, etc., etc. But this is something clean. You just give you a cheap energy, even if you don't care about the environmental problem. Just you get something which is cheaper and more accessible, and you can go out of the grid. So I believe that everyone will want it. Why not? I want it. I'm sure that you also want it.
Perfect. Thank you so much, Dr. Shaike. I hope our viewers enjoyed as much as we did today's discussion. As Dr. Shaike mentioned today, in our universe, an enormous amount of energy exists. The only question is how to use it in the right way. So hopefully we are on the right track as humanity. Dr. Shaike, we wish you success and good luck in your journey.
Okay, thank you very much.
And dear viewers, we wait for your questions in the comments and your feedback. Thank you so much for today.